The universe is a very bleak and dangerous place for humans, and Earth looks like the Titanic in it, an oasis in an endless desert. And the vast universe is full of dangerous, frightening and strange bodies. And the magnetic star, which is the result of an anomaly in the neutron star, appears as a living example of these dangerous cosmic bodies. Magnetic stars are considered highly dangerous and lie thousands of light years from our planet. The discovery of this rare type of neutron stars was confirmed in the year 1998. And although such objects were expected before, specifically in 1992, the most eye-catching feature of these bizarre stars is their incredibly strong magnetic field, which is estimated from 10 to 11 entertainments. And to understand the magnitude of this force, it can be compared to Earth's magnetic party index. At the Earth's core, the magnetic field is about 25 Gauss, and it's much less on the surface, around half a Gauss. Tesla fields are estimated at 10,000 Gauss, and the star is a neutron star. The one that spins abundantly and recurrently contains a magnetic field estimated at billions of Gauss, but the top of the indicator points towards the magnetic star, which is thousands of times superior, causing terror in the hearts of scientists. Initially, we must answer the most pressing questions about these strange stars.
How old are these stars?
The strongest magnetic star, or magnetar as it's called, has been in our world for a relatively short time, estimated at 1 million years, and the most active magnetic star in the universe, estimated to be 10,000 years old.
What are the sizes of these stars?
It's remarkable that the strongest object in the universe is of a miserable size, and its radius resembles that of an Earth colony. It measures about 20 or 30 kilometers in length. And it's fascinating to note that the size of these dwarfs starts from the sun and goes up.
How did it appear? Why is it hard for everyone to uncover the secret of its birth?
Magnetic stars are formed by an unbelievable force during the death of super heavy stars, which start from a mass equivalent to 40 times the size of the sun, in massive gaseous explosions that spread over vast areas of space. Then the core is incredibly compressed, to the extent that atoms stick together, then transform into neutrons, showing density of atoms among others. Why does a neutron star transform over a long period? What towards a magnetic star? This adds even more mystery to this immense force, and astrophysics doesn't give a clear answer about it. Scientists assume that during the birth of the pulsar, a strong magnetic field is formed, attributed to the presence in complex processes that can be reached when. And the active dyne called the second hypothesis that the magnetic star is part of a binary star system. Initially, they rotate very close to each other. It is likely that the same material will be exchanged. In the end, a single star explodes, casting away its companion and transforming into a magnetar due to the binary interaction.
How much does matter weigh on the star?
A small part of a star's material, the size of a tiny glass ball, could weigh more than Mount Jomolangma, which is about 100 million tons. And the most amazing thing about this star is its rotation rate, which could make a professional ballet dancer envious. Magnetic star is similar to the classic neutron star in its corona, but not fully. In many aspects, a spectrum of gamma rays close to X-rays is emitted. The nature of the appearance of these strong, constant flashes occurs in fractions of a second, making them attributed to different stars. And it's not just about the star's crust, which suffers from periods of activity when the magnetic star is formed. It is rather a dense crust and breaks like the Earth's tectonic plates. During the release of proton streams with the energy of 10,000 suns. The flare is noticeable at an amazing distance, and the magnetic star named SGM 1826 Sun, which is 50,000 light years away from Earth, and in a short time we received energy from it estimated to be what the Sun produces in 100,000 years. The explosion of the gamma rays was not just ordinary. Its impact was not only on the star's surface, but also had some effect on the upper layers of Earth's atmosphere, and needless to say, how dangerous the situation would be. Was a gamma ray burst at a close distance from our planet.
What are the chances of a dangerous explosion from a magnetar? that sends rays destroying our planet.
The vast Milky Way galaxy may be exempt.
Includes
60
3.
million of these dangerous stars, and so far, science has
I am
discovered
fine.
only 15 magnetic stars, the closest of which is this star. 1,849, 597 from the constellation of Al-Qaeda, was like it was about 9,000 light years away. And also SGRE 1900 plus 14, from the constellation Aquila, more than 6,100 parsecs from Earth. Despite the recent massive explosions, there was no disturbance in the Earth's ionosphere. But in 2013, a star named was discovered, SGR 17452-900, located about 30 light years from the black hole at the center of our galaxy. It is considered the only entity discovered near this place with a mass of 4 billion nurseries the size of the Sun. The main question exchanged here is what is the expected danger to Earth's inhabitants if there's a magnetar relatively close to us? The question of humanity's survival is indisputable, and making a mistake, here it's not just electronic, where all electronic communications on the entire planet would be immediately lost when gamma rays explode. Most information about those deadly rays is known to us, and if a magnetic star exploded in our galaxy and its radiation headed towards Earth, if the explosion is very far away, the Earth will not burn. But if it's closer, the penetration effect of gamma rays is equivalent to the effects of a nuclear explosion. This will lead to mass extinction. The magnetic field strength would simply tear apart the particles that make up all living organisms. But magnetic stars were rare and very far from our planet. There's no reason for us to fear Earth.